Hello everyone. In this video, I will be explaining problem A, B, C of Codeforces Round 975 Div 2. So, let's get started. Actually, I registered for this contest later. That's why my submission for the first problem is very late. So, in this problem, you are given an array A1, A2, AN, and the condition is that no adjacent element can be colored with color red, right? So what they want, your score is maximum value of red element plus number of red elements, right? So there are, let me just move to an example. See 545. Now red color you can give to 5 and 5, or another possibility is you can give to just 4, because you must color alternate elements. You can't color continuous. You must not have this condition that ai and ai plus 1 simultaneously have red color. So it's quite simple and implementable problem that you have to find out maximum value of all the red colors, and then you will be adding the number of red colors, right? So there are two possibilities. Either you can start coloring with first element, or you can start coloring with second element by skipping first element. So in this way there are two possibilities, and you can just calculate maximum of both. So in this problem you can see that what I have done, I have calculated sum1, sum2, count1 and count2. So sum1 is a variable which is will be storing maximum of first when I am starting from 0 index, coloring starting from 0 index, and in the other case it will be definitely starting from 1, then it will be odd case. So I can say sum 2 will be max of sum 2 and ai, and simultaneously I will be updating the both the counters that it is number of elements we have colored red, right? So finally I will be outputting maximum of both. So it's quite simple problem. So let's move to problem B. Yeah, so this problem is quite interesting, and it took a lot of time and mathematics to implement this problem. So in this problem you are given an x-axis from x1 to xn, right? Now you will be given some now you can make any you can pick up any I or j in the range 1 to n, and you can make the segment xi and xj, right? Both xi and xj are inclusive. So this segment, you can say this is one segment, and you can create any number of segment, whichever amount of segments creation is possible, right? So the segment are closed, which I have already told you. So try to listen this carefully, because entire problem is based on this statement. You are given q queries. In the ith query you are given a positive integer ki, and you have to determine how many points with integer coordinates are contained in exactly ki segments. So I read this statement multiple times. So let me again repeat for you that you are given q queries, and in ith query you are given positive integer ki, right? You will be given in ith query you will be given a positive integer ki, and you have to determine that how many points with integer coordinates are contained in exactly ki segments, right? So there are segments like this, and now the problem is asking that let's say 1 point, 2 point, or n points, whatever amount of points are included in ki segments, you have to answer those points. So that is the problem. So how I got approach to this problem, let me start explaining to you. I don't have experience of editor, so I will be explaining here only, right? So see in this problem, let us see the second test case, right? In the second test case, you are given firstly n and q, right? And then the array, and then the coordinates are x1, x2, xn, and then your queries. So see, uh, the very first observation I got that 1, 2, these are number of segments. So the problem is asking for this, that how many elements from all segments will be having will be belonging to only one segment, right? You can see from here you have to determine how many points are contained in exactly ki segments. So you have to find out that how many points are contained in exactly one segment, how many points are uh, included in exactly two segments. See, so for this problem you can observe that if n is 6, so very first observation what I did was that n minus 1 must be the number of segments. This value should be greater than n minus 1, because if you pick up any element it will be definitely belonging to n minus 1 segments, right? And total number of segments n particular element can belong to, uh, it will be n into n minus 1 by 2. So these two observation I got. But uh, after moving further, see, so what actually ultimately I just want that how many points will be included in one. So how can I do this? So I can just create a map in which I will be holding these number of segments and number of elements. So my ultimate task is to create a map corresponding to number of segment and number of elements, right? So how to create that map, that is the ultimate task here. So see, in this example you have 15 segments, right? And you can see in the first case 1, 0 0, and the answer 2 is when you can see that 1 and 7 are containing exactly 5 segments, 2, 4, 6. So here 5 segments, uh, there are two elements 1 and 7 which belongs to exactly 5 segments. So what you can conclude from here, that we will be using hash map, and let me just move to the solution to explain you easily. See, uh, I have just created an unordered map in which I have already told you that I will be storing number of segments and count of those numbers. So I initially taken the input of xi, and then I have initialized a variable I equals to 1. So I will be starting from first element till the nth element, right? I will be going from first element till the nth element. Now the thing you must observe and give time in this line only, that how you can find out the number of segments which will be included by this particular which in which this particular index number is present. So you can see, if you are at ith element, you are at first element, then I minus 1 elements will be in the left, n minus I plus 1 will be in the right. So you can combine these elements, and these number of segments will be possible in one case. If you are creating a boundary like from left to right including that particular xi, and there is another case if you include only xi and you don't include anything from left, then in that case n minus I should be added, right? So this is quite interesting to find out. I was initially using this to find out total, but to find out count, but I got this easily after this. So what I have done initially, see, if you are at particular element, then this element will be definitely belonging. So I just increase the count of corresponding to this segment, number of segment count. I just increase that one element is belonging. Now how I got this? See, so I have to check I is less than n because I must not go out of bounds. So see, you can see if I will be n, then I will be going, it will be out of bounds. See, if xi minus xi minus 1 will be my number of counts. So how I got it? See, let me just show you from here. See, the query is asking me that tell me how many numbers will be belonging to exactly one segment. See, you can just create one segment here 100, 1 to 200. And how many numbers are belonging in this segment? 200 minus 101, right? Plus 1. So this is the thing which I have written here. So xi minus 1. But why I have done minus 1? Because I have already increased it. In the case, in the last case, if I becomes n, then if I will not include this minus 1 here and this plus here, then I will miss out this last index value, right? So that's why I have increased map here, map value, and then updated it. So when I will be updating? Only if I am having any number of count, any numbers. So there might be possible, see, if you are having 200 and 101, then when you subtract opposite, you will be having negative numbers, and that is not the case we want to include. So that's why, and finally we will update this temp count with number of counts. So you can see, then we will again update I plus plus. So hence our map will be filled, and then for each query we will just uh, see out if map is having that particular number of segments value, then I will be outputting that, else I will be outputting 0. So this was quite interesting problem, and I think I took too much time over it to got this. Yeah, so let's discuss problem C, and I think C is much easier than problem B. It just required a little bit observation. So see, you are given some cards, an integer between 1 to n is written on each card, right? So you have AI cards which have number I written on them, right? So there is also shop containing unlimited cards. You have k coins, so you can buy at most k new cards in total, and the cards you buy can contain any integer between 1 to n. After buying the new cards, you must partition all your cards into decks according to the following rules. So see, you will be given some cards like this. I can just show you input like 3 to 2 means my card, 3 cards will be having number 1, 2 cards will be having number 2, 2 cards will be having number 3. So you can buy k more cards of any type of your choice from 1 to n. So if let's say after buying whatever amount of cards you have buy, then after buying the new cards you must partition all cards into decks according to the following rules. So actually, ultimately, they just want the partitioning of those cards in the which obey the following rules. So rules are all the decks must have same size. So all the decks must have same size. There are no pairs of cards with same value in the same deck. So they are asking that there must not come repetition in the same deck, right? So finally they are asking find maximum possible size of deck after buying cards and partitioning them optimally. So simply the problem reduced like this, that you have to use some k coins from can be 0 to k, and then you buy some cards, and then you include those cards in your available cards, and you try to distribute those number of cards with these rules, that no two same cards in the single deck, and all the decks must have same size, like this. So how we can approach this problem is quite interesting. See, in the first test case there are 3 2 2. So 3 2 2 means 3 1 2 2 and 2 3. So what we can do, we can buy as you can buy at most one. So let's buy a card with number 1 and make it 4 1. So when I will make it 4 1, then you can see this one will be separately in separate 4 containers, and then I can adjust other values inside it. So from this particular test case only, I got the observation that I can find out the maximum frequency element, and I will add if I will need to add, or you can say that if I can distribute other elements, the sum of frequency of other elements in these maxi number of cards or maxi number of decks, then it's my optimal answer, because these maxi number of decks must be separated. So my goal will be like this, that I will be having you can see I must create a maximum size, right? So this is my first observation, and let me move to the code to make the things more clear. See, so initially I have taken the input, and initially I have also calculated the entire sum, and yeah, see, entire sum and the maximum value, right? So the thing I was talking about will be hold in maxi. Now, this is Hindi word dabbe. See, so what I have observed, that now the problem is reduced like this. मैक्सी डब्बे हैं, क्या सम का मैक्सिमम डब्बों में इक्वली डिस्ट्रीब्यूशन पॉसिबल है? Means this sum is possible, is I can do the distribution of this sum if if I don't need you if I don't need to use k, or I can use k, right? So I have created a possible function. So see why I am traversing opposite direction from n to 1, because I just want uh, to the maximum value as asked in question. So is this possible? N with n sum maxi and k. I have passed all this. In this case, I will be just outputting this number of dabbe and returning. So how this possible function works, it's quite interesting. Let's say these are number of boxes. Let me count talk it as boxes, and these all are other variables. So I just count that if these are total values and I have to distribute them in these number of boxes, then can I distribute these? if can I distribute this, it will give some value to me. Then I just multiply to number of that value to number of boxes and see if it is lesser than some. If it is lesser than some, then I can directly return false. See, and in other case, if count I is lesser than maxi means I know that I have to minimum I need maxi boxes. So if count of boxes is lesser than maxi, then I just return false, and in other case I will return true. So this is my possible function, and hence our solution will be submitted. And again I can say that this line, this important line was to hold these rules, and the observation was to understand that whatever is the maximum value, the number of boxes can't be uh, lesser than that, right? So yeah, that's it for today, and keep grinding. You will also see good performance in your contest.